Hello everyone, hope you all are doing great. Guys, today in this video we are going to understand path manipulation in BGP. You know, path manipulation is most important part of BGP and this is the only reason why we are using BGP nowadays. Okay, so make sure if you are a network engineer you will watch this video till the end, because here in this video we are going to perform path manipulation by using BGP attribute. As you know, we have 12 types of attribute in BGP, but today in this video I am going to use 4 attribute for path manipulation. Like we will use attribute number 2, that is weight, attribute number 3, that is local preference. After that we will use attribute number 5th attribute is AS path, and then we will use metric for path manipulation. So we will use these 5 attributes for path manipulation in this video. Okay, but before starting the configuration, let me make you familiar with this topology, guys, because it is very important to understand topology first. Maybe video length can be long, but don't worry guys, if you will watch the video till the end, definitely you are going to learn lots of concepts of BGP in this video. Okay, so without wasting our time, let's begin. Here in the topology you can see this is my enterprises network. This is a network of a company. Let's say this is a network of PM Networking Private Limited. Here I am running AS number 500, right? I have 2 connectivity from ISP. Here you can see I have 1 connectivity from Sprint US and I have 1 connectivity from, actually 2 line from British Telecom router. I have 1 New York router over here, and on New York router I have some prefixes. So I will advertise these prefixes in BGP, and router number 1 will receive these prefixes from router 5 and router number 6 from both neighbor, because here I have configured BGP neighborship between router 1 and router 5 and router 1 and router 6. There is no any BGP neighborship between router 1 and router 3 or router 1 and router number 2. Let me design the logical topology over here. That means BGP topology over here. My BGP topology is like this. This is my router number 1. This is my router number 5. This is my router number 6. This is my router number 7. The Sprint US router. This one is my router number 8. British Telecom router, and I have one more router, router number 9 in New York. So this is my New York router. Here I am running BGP between router 7 router 8. I am running BGP neighborship between router number 5 and router number 7. Also I am running BGP between router 5 and router 8. I am also running BGP, and between router 6 and router number 8 I am using BGP, and here between router 1 and router 5 and between router 1 and router 6 I am running BGP. Done. So this is my BGP topology. Okay, here I am running BGP AS 500. Here I am running BGP AS 200. Here I am running BGP AS 100, and here I am running BGP AS 1, 2, 3, 4. Done. So now hope this is clear. Topology is clear to you, right? And I have formed BGP neighborship with loopback IP address. So as you know, 1.1.1 and 5.5.5 should be reachable with each other. For the reachability I am using OSPF protocol. For the reachability between loopback interface I am using OSPF in my enterprises network. Okay, so first of all let me show you the default configuration of BGP. I have access of all router 1. Here you can see I am running OSPF, so IP route OSPF. Through OSPF I have route for 5.5.5 for 6.6.6. Okay, and in BGP how many command I have run? So run section BGP. So here you can see I have advertised these network in BGP 10 prefixes. After that, neighbor 5.5.5 remote AS is 500, neighbor 5.5.5 update source loopback 1, and neighbor 6.6.6 remote AS number 500, neighbor 6.6.6 update source loopback 1. Right, because all loopbacks are reachable with each other through OSPF. So here you can see on router number 1 I have neighborship with router 5 and router 6 only. Done. Now if you will check BGP table over here, so IP BGP. So first of all, these prefixes are prefixes of New York router. I am running these prefixes on New York router. Over here you can see on router number 9 I am running these prefixes. Done, guys. So that's why on router number 1 you can see router 1 is getting these prefixes from both neighbor, from 5.5.5 also and 6.6.6 also, but from 5.5.5 it is best. From 5.5.5 it is best, and from router number 6, from this neighbor, it is getting same network information, but it is not best, it is only valid. So as you know, router is going to install these prefixes, actually all 192.168 prefixes via router number 5. So hope now it is clear to you that how router have installed this path, best path, as a best path from router number 5. Actually, by which attribute it is calculating best path? On the basis of, I think, lower neighbor router ID. Because first of all, router is going to check what? Next hop IP address. So both next hop is reachable. This is first attribute. Both next hop is reachable from here through OSP of 5.5.5 also and 6.6.6 also. If you want to verify, you can ping 5.5.5. Here you can see reachability is there. Ping 6.6.6. Reachability is there. So both next hop is reachable. So first attribute tie. Now it is going to check second attribute, that is weight. And here you can see weight value from both neighbor is 0 0, right? So second attribute also tie, weight is 0 0. As you know, for self advertised prefix, weight will be 32768, and for receive prefix, weight will be 0. BGP never carry weight information in the update, right? So from both side, weight is 0. Then it is going to check what? Local preference value. So local preference value over here is, you can see from both neighbor it is getting 100. Local preference value. So local preference value will be carried for iBGP neighbor. So both are 5.5.5 and 6.6.6. Both are my iBGP neighbor. So that's why local preference is 100 from both sides. Then it is going to check next attribute, that is self-advertised. So this network is receiving from both neighbor, right? Router 1 is not advertising this network. So it is going to check next attribute, that is ES path. So ES path from both sides is, from both neighbor is 100 and 123. From here also, from router number 5 and from router number 6. From both sides you can see ES path is same. Then it is going to check next attribute, that is origin code. Origin code is also same. I have advertised this network with the help of network command. So that's why origin code attribute is I. In previous video, we had already discussed the attribute. Then it is going to check what? Metric. So mat is 0 from both neighbor. Then it is going to check next attribute, that is external over internal. So both neighbor are internal neighbor. So this attribute also tie. Then it is going to check IGP cost to reach next hop IP address. So IGP cost to reach 5.5.5 and IGP cost to reach 6.6.6. So IP route 5.5.5.5. IGP cost is 3. Metric to reach 5.5.5 is 3. And IGP cost to reach 6.6.6 is also 3, I think. Yes, 3, right? So this attribute also tie. Then router is going to check what? Lower neighbor router ID. Oldest path is for eBGP neighbor. Both are my iBGP neighbor. So it is going to check lower neighbor router ID. And router number 5 have lower router ID. So that's why this router have installed best via router number 5. Done. On the basis of which attribute? On the basis of attribute number 11. Lower neighbor router ID. Okay. In the same way, New York router will receive this 10 prefixes from router number 8. Yes or no? So let me take you on New York router and let me verify that this router is getting 10 prefixes or not. So IP BGP. So yes, here you can see 10 prefixes are there, valid as well as best via router number 8. Guys, between routers, here suppose between router 5 and router number 7 I am using network 57.1.1.0/24. Here I have configured IP address 57.5 and here I have configured 57.7. Like this only I have configured IP address between routers. Done. Hope it is clear. Like between router number 1 and router number 3 I am using 13 network 13.1.1. 1.1.0. Here I am running 13.1. Here I am running 13.3. Done. Like this I have configured the IP address. Okay. So both router number 1 is also getting these prefixes, right, from both neighbor, but best is via router number 5, right? Best is via router number 5. Okay. Now what I want to install these prefixes in the routing table of router 1 via router number 6. So first of all, I am going to manipulate the path by using weight value. So by default, weight is 0 from router number 5 also, and from router number 6 also weight is 0. Now I am going to increase the weight from router number 6. If I will set weight value 100, so this path will become what? Via router number 6 will become what? Best. Yes or no? Because higher weight is always preferred. So let me do that. Let me take you on router number 1, guys, directly. So till now, here you can see this network. This all network is best via router number 5. Now I am going to add some weight value, because now weight is 0, right, from both neighbor. So let me take you in the global config mode. After that, router BGP 500, and I am going to say your neighbor 6.6.6.6. I'm going to say neighbor 6.6.6 and weight. For this neighbor I am going to add weight 100, let's say. Done. And now if you will clear IP BGP star soft in, and now if you will check BGP table, so IP BGP, so you can see now this network 192.168.20.0 is best via router number 6, because here you can see the weight value is 100. Here weight value is 100. So via router number 6, router 1 is getting prefixes with weight 100, and via router number 5 it is getting weight 0. So on the basis of weight, second attribute, now router 1 is performing best path selection, and router 1 have installed all path in their routing table via router number 6. You can see reachable via 6.6.6.6. Okay, this is the first way for path manipulation, but here we have some problem. Problem is, suppose on router number 2 also I am running BGP. So you have to change weight value manually on all routers, because as you know, BGP does not carry weight information in the update message. So weight is locally significant. You have to change weight value on all routers. So that's why we are not using weight value for path manipulation over here. So let me remove the command router BGP 500 and neighbor 6.6.6 weight 100. I am going to remove this command from here. Done, guys. Now again, if you will check BGP table, so IP BGP, after clearing BGP table, so IP clear IP BGP star soft in, and so IP BGP. Still, now you can see again best is via router number 5 on the basis of lower neighbor router ID. Router is performing best path selection. Done. Now I am going to perform path manipulation by using local preference. Okay, so what is happening over here? When router 5 is advertising prefixes, these prefixes, right, to router number 1, local preference value is 100 by default. When router 6 is advertising, local preference value is 100, right? So from both sides local preference value is same. Now what I am going to do, I am going to make best path via router number 6. So on router number 6 I will increase the local preference value. Here I will set local preference value what? 100. Done. 100. Or what I can do, I can tell to router number 6 that whenever you will receive any prefix from British Telecom router, you will add weight 101 or 100, let's say 10. So it will add weight value, not weight, local preference value 110. So now if router 6 will advertise these prefixes to router number 1, it will advertise with weight with local preference value what? 110. And when router number 5 will advertise, it will advertise with local preference value 100. So which path will become best, guys? Again via router number 6. Yes. So let me do this also. now I am going to take you on router number 6 and see if I will increase the local preference value on router number 6 for incoming BGP update. So it will manipulate path for on all routers, right? On router 2 also, on router number 3 also. Suppose there is one neighborship between router 2 and router 6 and router 2 and router 5. So router 5 will also advertise these prefixes to router 2 with local preference value 100, and router 6 will advertise it with local preference value at 110. So router 2 will also install best path via router number 6. So this is not locally significant. So if I will add local preference value on router number 6, then path will be manipulated for all routers in my AS. Done. Now let me take you on router number 6, and here I am going to add some weight. Enable config T not weight local preference value. And to add local preference, you have to create one route map, as you know. Route map, after that name. So I can say name is, let's say, LP, means local preference, and permit. Here I am going to set local preference value 110. Now I am going to use this route map with BGP. So router BGP 500 and your neighbor is 68.1.1.8. This is the neighbor router ID of router 6. This is the IP address which is running on router 8, which is connected with router number 6. And I am going to use route map. Name is LP, and in which direction you want to use it? In direction, that whenever you will receive any update message from British Telecom router, you will use this route map. And in this route map, I have add local preference value 110. So I am going to say direction in. Now clear IP BGP star soft in. Done. And see show IP BGP over here now. So you can see local preference value over here is 100. So whatever prefixes router 6 will receive from router number 8 from their neighbor 68.1.1.8, it will add local preference value 110. And in the same way, you can verify it on router number 1 also. So on router number 1, if I will run command, so IP BGP now, you can see via router number 6, local preference value is 110, and via router number 5, local preference value is 100. So on the basis of third attribute, local preference attribute, router 1 is performing best path selection. And if you will check routing table, so IP route BGP, so you can see it have installed all paths via router number 6 now. Done. This is the second way for path manipulation, right, by using local preference. So all prefixes is received via router number 6 now. Now guys, suppose my requirement is suppose here from router number 1, if you will ping 192.168.10.1, so all traffic will go via router number 6 only, yes or no? In New York, all traffic for all networks. But my requirement is, suppose I want to use both paths, this path also and this path also. What is my requirement? Let's say for upper 3 prefixes, for these 3 prefixes, best path should be via router number 6, and for these 2 prefixes, best path should be via router number 5. So what we can do, for these prefixes we can add local preference value on router number 6, and for these 2 prefixes I will add local preference value on router number 5. For that we have to define interesting traffic. Okay, so you can calculate the summary address of these 3 network. Summary address will be 192.168.0.0/22. So let me see how I am going to, first of all let me remove the previous configuration. Router BGP 5000 and say no neighbor route map LP direction in. Done. I have removed this configuration. I'm going to remove route map as well. No route map LP. Done guys. Now see what I will do. And guys, now we are performing path manipulation for outbound traffic, the traffic which will exit from my AS. So Now all traffic will exit from my AS via router number 6. But now my requirement is different. For these three prefixes, it should exit via router number 6, and for these two prefixes it should exit via router number 5. So let me take you on router number 6 directly first. Here I am going to create one prefix list to define interesting traffic. So let's say IP prefix list, and name is CCI permit, and then summary address of upper 3 network is 192.168.0.0 slash value will be, so what will be the binary of 10. You can calculate the summary address of these three network. Let me calculate the summary address first. Summary address will be this one, 192.168.0.0 slash 19, and greater than equal to 24 and less than equal to 24. This is the summary address. Here we have defined upper 3 network. Okay, done. Now I am going to create one route map, and in that route map I will call this prefix list where I have defined the upper 3 network. Okay, route map name is, let's say, LP, and say permit. Done. After that I am going to say match IP address from prefix list CCI. Yes or no? This is the name of my prefix list, no? Yes, CCI. Done. So it will match IP address from this prefix list, and then I am going to say set local preference value what 110. Done. So if you have matched the IP address from this prefix list, as you know, by default implicit deny is configured, so you have to create one more route map with same name, LP, and permit, and higher sequence number, let's say 20. I am not going to match anything, so it will match all, so it will allow all other traffic. Now I am going to use this route map pin BGP. So router BGP 500 and neighbor 68.1.1.8 use route map whose name is LP, and direction will be in. Clear IP BGP star soft in. Done. Now on router number 1 you can verify the BGP table. So IP BGP, here you can see 192.168.10.0 is best via router number 6 because local preference value over here is 110. For this network also, 20 network also, local preference via router number 6 is 110. For this network 30 network also, local preference via router number 6 is 110. But for these three prefixes, for last two prefixes, local preference value is same from both neighbor, so best is via router number 5. Best is via router number 5. So these two prefixes are best via router number 5, and these three prefixes are best via router number 6. So if you will check BGP routing table, so IP route BGP, so you can see these upper 3 network is reachable via router number 6, and these two network are reachable via router number 5. And for these two network, what you can do, you can add some more some local preference value on router number 5 also, right? But it is selecting best path for these two network on the basis of lower neighbor ID, and these three, for these three prefixes best path selection is happening on the basis of local preference. Done. So I have achieved my requirement. Done. And see, on router number 5 also I am going to set some local preference value for last two prefixes. So what will be the summary address of last two prefix? In the same way, you know, I am not going to perform it. You can calculate the summary address of last two prefix, and like how I have configured the route map on router number 6, same in the same way you can configure the route map on router number 5 also for the lower two prefixes. Done. This is the second way for path manipulation, done by using local preference value. Okay, now I am going to remove the configuration from router number 6. take you on router number 6 and say router BGP 500 and neighbor this one route map LP direction in, say no, right? No route map, no route map LP. Done. I have removed the configuration. So till now we have discussed the path manipulation for outgoing traffic which will exit from my AS. Yes or no? Now again, if you will check the BGP table of router 1, so it will be install all paths via router number 5. Clear? IP BGP star soft in. So IP BGP, now you can see still it is via router number 6. Let me do one thing. On router number 6 I need to clear the BGP table. Clear IP BGP star soft in. Done. Now let me take you on router 1 and here if you will show IP BGP, so IP route BGP, you can see all prefixes are reachable via 5.5.5.5 means from neighbor router 5. Done. So till now everything is okay guys. If you have any doubt you can let me know in comment, no problem, I can make short video okay on that. Now I am going to perform path manipulation for incoming traffic, for traffic which will enter in my AS. Like suppose if I will ping 192.168.10.1 from this interface, from suppose 10.1.1.1, router 1 will forward traffic to router number 5. Actually when I will ping 192.168.10.1 and let's say source is 10.1.1.1, so router 1 is going to check their routing table. Router 1 will check their routing table and it will see 192.168.10.0 network is reachable via router number 5, so it will forward the traffic to router number 5. Then router 5 will do what? Router 5 will check their routing table to forward traffic in 192.168.10.0 network. So IP route BGP. So here you can see 192.168.10.0 network is reachable via 58.1.1.8. So it is going to forward the traffic to British Telecom router, to this router, and then British Telecom router will check their routing table. And so IP route BGP, here 192.168.10.0 network is reachable via 89.1.1.9, so it is going to forward traffic to router number 9. Okay, then router number 9 will do what? Router number 9 will generate reply. In the reply, source IP address will be 192.168.10.0, 10.1, and destination IP will be 10.1.1.1. This New York router is going to check their routing table and it will forward traffic to British Telecom router. So IP route BGP. So you can see 10.1.1.0 is reachable via British Telecom router. So it will forward traffic reply to router number 9, router number 8, sorry, to this router. Now router number 8 will check their routing table. So in the routing table, here you can see 10 prefixes. 10.1.1 is reachable via 61.1.1.6. So it is going to forward traffic to router number 6. Yes. And router number 6 will check their routing table to forward traffic in 10 network. So let me show you the routing table of router 6 also. So IP route BGP. So here you can see 10.1.1 is reachable via 1.1.1. Directly router 6 will forward traffic to 1.1.1.1. So see, my traffic is going from my AS to other AS from router number 5, and traffic which is coming in my AS is via router number 6. This is nothing but asymmetric routing. This is my path for incoming traffic for outgoing traffic, and this is the path for incoming traffic. Yes or no? This is a path for incoming traffic in my AS. Done. Now I want to perform path manipulation for incoming traffic which is coming in my AS. So what we can do for incoming traffic on British Telecom router, I can add local preference value or weight value to with this neighbor. Here I can add weight value 110, let's say. So router 1 will install these prefixes in their, sorry, not these prefixes. Router number 8 will install these prefixes via router number 5. If I will add weight value over here 110, if I will add local preference value 110 via router number 5, router number 8 will install these prefixes via router number 5. So it will forward traffic to router number 5. Then path will be like this. Yes. Guys, whenever you will perform path manipulation in BGP for incoming traffic, you will always manipulate path by using AS path attribute. Because here on British Telecom, we cannot configure what? Local preference value or weight value, because British Telecom is not going to give me the access of their router, yes or no, in real time. So whatever things you can do, you can modify the configuration, you can modify on your router only, on router number 5, on router number 6. So without touching the router of British Telecom, you have to perform path manipulation. So what we can do, we can add some AS path. We can add some AS path on router number 6 with neighbor router number 8. So what will happen then? From here it is receiving 10 prefixes with AS number what? Let me take you on router number 8 again, and here show IP BGP. In BGP table you can see for 10 prefixes there are 3 paths. Yes or no? It is receiving via router number 7 also, receiving via router number 5 also, and receiving via router number 6 also. Via router number 7, AS path is 200 and 500. Via router number 5, AS path is only 500, and via router number 6, AS path is only what? 500, right? So via router number 5 and router number 6, AS path is tying. Yes or no? So it is going to check next attribute. So what I can do, I can increase the AS number over here via router number 6. Via router number 6. So when British Telecom will receive these prefixes from router number 6, suppose here I am adding one AS number 100 more, 100, or let's say 600 AS number I will add over here. So what will happen? Router 6 will advertise these prefixes to British Telecom with 2 number of AS 500 as well as AS 600, but router 5 will advertise it with AS 1 number of only one AS, that is AS 500. So definitely router 8 will install it via router number 5. Okay, so actually you need to perform path manipulation by modifying the configuration of your router. So that's why we are using what? AS path for incoming traffic. For incoming traffic. So let me take you on router number 5, and here see how I can perform path manipulation. I will create one route map. Let's say name is AS_path. Say permit, and I am going to set AS path, and you need to add, so prepend. Prepend means adding. Now here I am going to add some AS number, let's say 200 or 111. Twice I have add 111 and 111. Done. In this route map, now I am going to use this route map with BGP, router BGP 500, and say neighbor, your neighbor 58.1.1.8, 58.1.1.8, use route map AS_path, and in which direction? In odd direction. You will always apply AS path attribute in odd direction, right? So actually whenever router 5 will advertise 10 prefixes to this neighbor, it is going to use route map in odd direction. Done. Now let me clear the BGP table. Clear IP BGP star soft in. Done. And now on router number 8 on BT's Telecom router, if you will check BGP table, so IP BGP. So IP BGP. Now you can see this network is reachable via, still reachable via router number 6. Here also I need to clear IP BGP star soft in, and so IP BGP. Now best via router number 6, because here AS number is, AS path is only 500, and here via router number 5, how many AS path is there? 500, 111 and 111, right? So that's why it is installing via router number 6. Now you want to make best path via router number 5. You want to receive all traffic in your AS via router number 5. So what you can do, you can add some more AS number via router number 6. So let me remove the configuration from router 5, guys. A router BGP 500 and say no neighbor, this one route map AS path, no route map AS underscore path. I have delete the route map configuration. Now on router number 6 I am going to add AS path. Config T route map AS underscore path, say permit, and set AS path prepend 111 111 111 111. Done. After that, router BGP 500 and your neighbor 68.1.1.8 use route map AS underscore path and direction is out. Clear IP BGP star soft in. Now let me take you on router number 8. Here also I need to clear IP BGP star soft in, and so IP BGP. Now you can see all prefixes, 10 prefixes is best via router number 5, because from router number 5 it is getting prefixes with AS path 500, but when it is receiving prefixes from router number 6, it is getting 4 AS path, 4 number of AS, and least number of AS is always preferred. So that's why via router number 5 it have installed the best path. Right now I am going to remove the configuration, this configuration, and let me change my requirement. A router BGP 500 and say no neighbor, this one, and after that let me remove route map as well. So no route map AS underscore path. Done. Now my requirement is, suppose whenever any user from outside, from let's say New York router, want to reach in these network, these 3 network, it should reach via router number 6, and whenever this user from New York router want to reach in these 2 network, it should reach via router number 5. So what you will do, for these upper 3 networks you will increase the AS number over here. For these 2 network you will increase the AS number over here. Yes or no? So let me do this also. So on router number 5, first of all I have to define the interesting traffic. So I have to create one prefix list, or you can create one access list as well, right? Either you can configure access control list or prefix list to define the interesting traffic. I am using prefix list. Prefix list CCIE permit, and what will be the summary address of upper 3 network? 10.1.0.0 0/22 greater than, this is the summary address, you can calculate, greater than equal to 24 and less than equal to 24. Now I am going to create one route map. Name is, let's say, AS underscore path and permit. Match IP address prefix list CCI. It is going to match IP address from prefix list CCI, where I have defined the summary network, and I am going to set AS path prepend 111 111 and let's say 2.222. Done. I am going to use this route map in BGP. So router BGP 500, your neighbor 58.1.1.8, use route map AS underscore path, and in which direction? In odd direction. Done. Now here you can run clear IP BGP star soft in. Done. Okay. Now on router number 8, let me check BGP tables. Clear BGP table. So here also I need to clear IP BGP star soft in, and now if you will check BGP table, you can see this prefix 10.1.1.0 is best via router number 6, because via router number 5 it is getting 4 number of ES. Okay, this is also best via router number 6. This is also best via router number 6, but this network is still best via. This is also best via router number 6, but here AS path is only 500, and via router number 7 AS path is 200 and 500, right? So actually this network is not, this router is not receiving this network from which neighbor? From router number 5, from neighbor 5. So actually, you know why it is not receiving? Because here you have on router number 5, you have created the route map. In the route map you have matched the prefix list, so all other traffic will deny automatically. Say you have to create one more route map with permit statement. Name was AS underscore path with same name and permit, and let's say AS number what 20, sorry, sequence number is 20. So I have created one same route map with permit statement with higher sequence number, and now I am going to clear IP BGP table, clear IP BGP star soft in. Or if you want to clear the BGP table with neighbor, so that also you can do. Now on router number 8, if you will check BGP table, clear IP BGP star soft in, and so IP BGP. So see guys, this network till here all prefixes are best via router number 6, and this is also best via router number 6 because of oldest path. So what I am going to do now, for these two prefixes I am going to add AS number on router number 6, so it will install best path via router number 5 for these two prefix, for lower two prefix. Because for upper three prefixes you can see via router number 5 it is getting 4 number of AS, but via router number 6 it is getting 1 number of AS only. So definitely it will use this path as a best path. Done. Now let me see, take you on router number 6, and here also I am going to create one route map. First of all I have to define the interesting traffic. So what will be the summary address of last two network? It will be 10.1.4.0. So IP prefix list name is, let's say, CCI permit, and 10.1.4.0/22 greater than equal to 24 and less than equal to 24. Done. Now route map AS underscore path, this is name, you can set any name. After that permit, and I am going to match IP address from prefix list CCI and set AS path prepend, let's say 888. I have add 3 ES number here. Again I need to create one route map with permit statement. So route map AS underscore path permit, and let me give higher sequence number, that is 20. A router BGP 5500 and neighbor 68.1.1.8 use route map as underscore path, and in which direction? In odd direction. Done. Now clear IP BGP star soft in. See on router number 8. Clear IP BGP star soft in, and so IP BGP. So see guys, now these three prefixes are best via router number 6, and these two prefixes are best via router number 5, because via router number 6 it is getting 4 number of AS, via router number 5 it is getting only 1 AS number. So definitely best is via router number 5. So now if you will check routing table, so IP route BGP, so you can see upper 3 network is reachable via router number 6, these 3 network, and lower 2 networks are reachable via router number 5. Okay, so now whatever traffic will come in my AS for these 3 network, it will come via router number 6, and whenever traffic will come for these 2 network, it will come via router number 5. Done. So hope it is clear to you. If you have any doubt, you can let me know in comment guys. I will make one more short video on that, no problem. Now I am going to remove it, and I am going to perform path manipulation by using last metric, that is MAD, right? So let me take you on router number 5. Here I am going to remove the configuration first. Router BGP 500 and neighbor, this one, say no. I'm going to remove the route map as well. No route map, and route map name was AS underscore path. Let me remove prefix list as well. No IP prefix list, CCIE. Done. In the same way, let me remove configuration from router number 6 also. A router BGP 500 and neighbor, this one, say no. Done. No route map, AS underscore path, and no IP prefix list, CCIE. Done. I have removed the configuration. Again, if you will check BGP table of router number 8, clear IP BGP star soft in. And now again, if you will check BGP table, so IP route, let's say BGP, so you can see all 10 prefixes are reachable via router number. Not best. Okay, just wait. So IP BGP best via router number 6, best via router number 6, best via router number 6, but best, this one is best via router number 5. So this is because of oldest path, that is selecting best path on the basis of 10th attribute. So what I am going to do, I am going to down the neighbor 5, so it will install all path via router number 6. A router BGP AS number over here is 100 and neighbor 58.1.1.5 says shutdown, right? And again I am going to say no shutdown. So on router number 8, let me clear IP BGP star soft in. And now if you will check BGP table, so IP BGP, you can see all prefixes are best via router number 6. All prefixes are best via router number 6. You can check the routing table as well. So IP route BGP via router number 6, it is best, right? Now, like AS path, we can use MED as well, MED attribute as well for the incoming traffic. For incoming traffic, actually we are using AS path and MED attribute. For outgoing traffic, we are using wait and local preference attribute for path manipulation, guys. Done. So now I am going to use what? MED. So on router number 8, if you will check BGP table again, so IP BGP, you can see 10 prefixes is best via router number 6, and metric from all side is blank. Yes or no? So now what I am going to do, from router number 6 I am going to add some metric. I will add some metric value. So what will happen? Suppose here if I will add metric of 100. So router number 8 will receive prefixes, 10 prefixes from router number 5 with metric what 0, and from router number 6 with metric 100, and lower metric is always preferred, so it will install all path via router number 5. Then okay, let me do this also. Let me take you on router number 6, and again I am going to create one route map, and this time name of route map is, let's say, MED, and permit. Here I am going to set metric, let's say 100. Done. Now router BGP 500 neighbor 68.1.1.8, use route map, name is MED, and in which direction? In odd direction. So you will always apply local preference and wait value. You will apply local preference and wait value in direction, and you will apply AS path and MED in odd direction. Okay, so here I have applied this. Now clear IP, and directly I am going to run clear IP BGP command on router number 8. Clear IP BGP star soft in, and now if you will check what BGP table, so you can see, so IP BGP, all 10 prefixes are best via router number 5, because via router number 6 you can see metric is 100. Okay, you can capture the link as well. Suppose I want to capture this link. Let me capture one link over here. Which link? Which port it is? F2/0. F2/0. I am going to capture this link. And on router number 6 I am going to run clear IP BGP command. Clear IP BGP star soft in. Done. Now this router is going to send BGP update message, router refresh message, here you can see, and in this if you will check the attribute, so this is update message of router 6. If you will open it, okay, so this is update message. Here I am going to open this one, and here you can see the path attribute MED attribute is what? 100. So when router 6 is sending these prefixes, it is sending MED value what? 100. When router 5 will send it, it will send MED value blank. So router 8 will install with path, which path? Via router number 5. So this is also a way for path manipulation in BGP. On router number 8 you can run command show IP BGP, and you can see all prefixes are best via router number 5 now, because here via router number 6 it is getting MED value 100, and here it is getting MED value what? blank. Okay, so IP route BGP. See, all prefixes are reachable via router number 5. So now my incoming path and my outgoing path is this one. Yes or no? Okay, now my requirement is, suppose for these three prefixes I want to add metric over here. So it will install these three prefixes via router number 6, and for these two prefixes I will add metric over here, so it will install best path via router number 5. So if you want to you do that, so also I can configure, but before that I have to remove the previous configuration. So config t router BGP 500 and say no neighbor route map. This, let me remove the route map as well. Say no route map mat. Done. Now again I have to define interesting traffic with the help of prefix list or access control list. You can define the interesting traffic. Let me configure one IP prefix list. I am creating prefix list for upper 3 networks. Okay, name is, let's say, CCI, and again permit 10.1.0.0 slash 22 greater than equal to 24 and less than equal to 24. Done. Route map. After that, made mat permit and match IP address from prefix list CCI and set metric, let's say 100. Okay, need to create one more route map with same name with higher sequence number for permit rest traffic. So route map mad permit 20 exit router BGP 500 and neighbor 68.1.1.8 use route map mad and direction is out. Done. Now in the same way I have to configure router number 5. Here I am going to add metric for lower 2 networks. So IP prefix list CCI permit and 10.1.4.0 slash 22. This is summary address of lower 2 networks, and greater than equal to 24 and less than equal to 24. Route map mad permit match IP address from IP prefix list CCI and set metric. Let's say here I am going to set metric what, 500. Any metric you can set. I need to create one more route map mad permit higher sequence number 20 router BGP 500 and neighbor age 58.1.1.8 use route map. Which route map? Mad. And in which direction? In out direction. Done. Now if you build clear IP BGP on router number 8, clear IP BGP star soft in and so IP route BGP, you can see these three networks are reachable via router number 5 and these two networks are reachable via router number 6 because so IP BGP. Here you can see this network 192.168.10.0 is getting from 3 side, but here you can see it is getting metric what 100 via router number 6, getting blank metric via router number 5. But for these two network getting metric 500 via router number 5 and getting blank metric from router number 6. Okay, so these are the way for path manipulation in BGP, guys. Now if you have any doubt, you can let me know in the comment section. Definitely I will, within my capacity, I will try to resolve your doubt Okay, that's all for today. If you have learned something from this video, please hit on like button. If you have not subscribed this channel, please subscribe this channel, guys. If you want this type of more video, please click on bell icon so that whenever I will upload next video, you will get notification. Okay, that's all for today. Bye bye, see you in next video.